Hello there and welcome to the second part of lecture 4. Today we'll talk about the bulk flow. And the bulk flow is just when the mass movement of a fluid into the out of the capillary bed, when we see that the exchange happen between oxygen and CO2, it just like required a transport mechanism far more efficient than diffusion. And this movement is referred to as bulk flow. Okay, and there is two pressure driven mechanism they are working out. We have volume of a fluid moving from the area of the higher pressure in a capillary bed to the area of low pressure in the tissues we name filtration. We will understand them inshallah in the next slides. The movement of a fluid from the area of higher pressure in the tissue into the area of lower tissue in the capillaries is named reabsorption. So we have two, let's say, um, we have, okay, this is the capillary bed, and this is the tissue outside. Okay, so it just like moving from higher pressure here to outside, from the higher pressure from the capillary bed to the lower pressure of tissue, we name it as filtration. F, I will name it F filtration, and moving from a high pressure in the tissue to the lower pressure of the capillary bed. So in the opposite side, we name it reobservation. I will write R. Okay, these two movements controlled by two pressures. One of them we name hydrostatic pressure, and the other one we name it as osmotic pressure. Okay, what is the hydrostatic pressure? The hydrostatic pressure, before I reading it to you, hydrostatic pressure is just like if you have, for example, a source of water here. Okay, this is source of water, pushing water, and you have a tube here. This tube have holes here. Okay, and when the water is just going out, you will see the water will be go out high column on that area, while it's going is low column on that area, and go lower here. Why? The reason of this why. Here, the force is higher. Why the force is higher? Because it's close to the source of the area, the close of the source of the water, while here, or source of the liquid. While here, it's going to be lower because you are far away from the source of the water or source of the liquid. Here you go to further decrease of the pressure because of the source. And you know that the pressure is force per area. So the pressure will be increased when the force will be increased. When the force will be increased when you are close to the source of water. When the pressure will be decreased when you are close, when you are far away from the source of the water. And this one we name it as a capillary bed. Okay, and you can see here from the artery, this is the source of the blood. The heart is here, so the blood is just moving from this side. So what you expect to see here, expect that it will be higher pressure here. Why? Because you are close to the heart. While expect to see here, you are the low pressure of the heart. Okay, so because you are far away from the heart, it will be at the low pressure. Okay, so this one we name it hydrostatic pressure, which means the pressure of any fluid enclosed in space. And it's just like we name it as a capillary hydrostatic pressure. Okay, capillary hydrostatic for us, for this case, for our case, we name it capillary hydrostatic, or CHP. Okay, and CHP is the force that drive the fluid out of the capillaries into the tissue. So from the capillary to the tissue outside, which is we name it before is filtration. Okay, this is the CHP. Okay, what about the osmotic pressure? The osmotic pressure is just like when you have a fluid with a low concentration of some molecules with it. So let's see, low concentration. All right, and you have a cell membrane here. A cell membrane is just like you can move fluid or like a small size molecules and prevent the high size molecules or big size molecules to be move in. So just like if you have a water with the low concentration and the water with the high concentration here, the osmotic pressure is moving of the solvent of the water from the low concentration to the high concentration to make the equilibrium. Okay, so here there's no equilibrium. On that side you have low concentration. Here we have high side on high concentration. While here, when the water moving or fluid moving from the low concentration to the high concentration, we make the same concentration for both of them, which is near equilibrium. Okay, and in terms of the our case of the capillary, the moving the fluid from the cells, this is the capillary, from the tissue to the capillary, it will give you what? It will give you the hydrostatic, or they will give you the osmotic pressure. In terms of the capillary, we name it the blood collide osmotic pressure, BCOP. Now, how can these two working together? First of all, you have from here, you are just the heart is on this side. Okay, so the blood coming from this side. When the blood coming to this side, what you will see, let me draw it here for you. So you have this one. Okay, this is the arteriole A, I will write A, and this is the venole, we name it V. So when the blood coming from this side, okay, and then you what you expect? You expect the blood will be go, or the fluid will be go outside from here with the high pressure, which is like near to the 30 millimeter mercury. Why it's high here? Because of the you are near, as the hydrostatic pressure said, you are near to the source of the pumping the blood, which is the heart. You have high pressure. While the osmotic pressure, I will change the color for the osmotic pressure. While the osmotic pressure, you will see it as low here. And this is the capillary, of course, and this is the tissue. All right, so it will be 20 millimeter mercury. 20 millimeter mercury. So when they are 20 and 30, which one will be win? They will fight each other. Which one will be win? Of course, the higher pressure will be win. So the blood will be, or the fluid will be moving outside, carrying the oxygen with it to the tissues. When the blood moving on side here, you are far away from the we are far away from what we name it as the heart, the source. So that's mean the osmotic pressure will be reduced now. The hydrostatic pressure, sorry, will be reduced. It will be near to be just like maybe 18 millimeter mercury, 18 millimeter mercury. While the, sorry, while the, let me change the color, while the osmotic pressure is going higher, 25 millimeter mercury. Okay, so now which one is bigger? The one is bigger is 25 millimeter mercury. That's mean you will have what? You will have the blood or the fluid moving from outside from the cell to be go inside to the from the tissue to the capillary bed. Okay, carrying the CO2 with it. Here carrying the oxygen with it. All right, and in the middle here, both of them they have the same value. So no exchange will happen. So in the middle, no exchange. In the starting of the venule, the fluid will be moving outside and using the filtration process. And from the end of the close to the venule, it will be the reabsorption process, which is the fluid will be going inside. And this one, we name it as a capillary exchange. And this is the end of part 2. Thank you very much.